bad. You know, if we get through today, it's downhill the rest of the week, right? Because you passed the longest part. Now you're the closest to the weekend. Oh. Okay. All right. Well, so last time I was gone, I left you guys a video to watch and a homework assignment to work on. Let's start by just kind of taking any general questions that we might have from that. So if you guys want to take out your assignment, and we'll take any questions that you guys might have. Natalie?
Number 15.
Okay. Okay. So this is just a intercept form polynomial. So all I need to do is FOIL it, but really it's even easier than that since it's just a monomial times a binomial. I can just distribute it across, then we're done. So there wasn't much to do there. It looked like maybe like, oh, what do I do with that? But it was easier than maybe we thought, right? Yeah, no problem. You can ask questions for any reason you want, even if it's just to like see what the right answer is. That's cool. No big deal. Yeah, so we're just gonna, again, we're trying to get this into standard form. So this is intercept form. To get it to standard form, we FOIL. So, oops. Hold on real quick here. I don't want to do that. I almost was doing the notes in the wrong spot. You know what I mean, guys? Sorry to stop midway through. I'm just... Oh, you stupid piece of junk. I'll do it this way then. Sorry about that. I realized I was doing something, putting this not. So first, outer, inner, last, combine our like terms. There we go. Cool? Good. Good. Last call from this sheet before we start up with some new stuff, Maddie? Sure. So here we're just asking whether it's in intercept form, vertex form, or standard form. 8 you could interpret as either vertex form, where the h is -1, the k is 0, and the a is 1, Or you could have thought about it as intercept form, where the A is 1, the P is -1, and the Q is -1. Either of those two responses would be correct, and really you should have written both of them. Is that, you see why it's both? Mm-hmm. Okay. So that one was a little bit sneaky there, a little sneaky. But that's okay, because I think largely this should have been a fairly easy first section, right? Nothing too tremendously complicated going on here. Last call. Joe? You mumbled, when will it be a polynomial? And then I got a bunch of mumbles. I didn't hear. How do I know if it is? If it's the sum or difference of monomials? So a monomial is a real number times a variable or variables whose exponents are non-negative whole numbers. Okay, that's what you needed? You'll figure it out. Well, I like the attitude. Okay. So starting today, so last time we had talked about quadratics, and we talked about how to move back and forth between the different forms. And really, I think last time we focused mainly on these two paths, right? Agreed? Today we're going to focus on the other two. So the other two paths are factoring and then completing the square. So those are the two topics we're going to do today, and we'll see where we're at after that point. Okay with that? Okay. So let's start with the factoring. So the idea here, this is the reverse of FOIL. So let's kind of start with a FOIL problem, and then we'll use that as our guideline for how to develop a procedure to do factoring. Okay with that plan? There's our FOIL example. Okay. So we're talking about factoring, which is going from standard form to intercept form. But notice that that's like the reverse direction as foiling. So we're using that as kind of our as our example to justify the steps that we're going to do for factoring. Okay with that? So here, we're starting with x squared plus 4x minus 21. And we need to somehow justify here. So we need to figure out how to know to break 4x up into negative 3x and positive 7x, right? Well, obviously those add up to give 4x, but why wouldn't I do 5x and negative 1x? Or 10x and negative 6x? Or 1000x and negative 996x? So we need to have a rule, that looks like Ella's trying to tell me what the rule is, for how to know how to break those two, or break that number 4x up into two separate numbers. Yeah, so the rule here that we're going to use, we need the two numbers to multiply to give us the A coefficient times the C coefficient. It would also have to add to give us, which in our case is 4. So that two numbers here is clearly positive and negative 3 are the only two numbers that are going to satisfy that. Is everybody okay with that reasoning? We'll use that rule every time we want to factor to some extent. Worth saying a couple of things here before we move forward. Which problem should I start looking for my answer with? The multiplication problem or the addition problem? Always the multiplication problem, because how many pairs of numbers multiply to give us negative 21? Well, really 4, right? Because the signs could switch. Like 1 and negative 21, or negative 1 and positive 21. 3 and negative 7, or negative 3 and positive 7. But there's only 4 pairs of numbers that are going to do that. How many pairs of numbers add to give us 4? Infinite, right? 0 and 4, 5 and negative 1, 6 and negative 2, 7 and negative, and you keep going and going and going forever, right? So which list should we check, use to do our checking? The finite list. Let's start with the multiplication problem, and then check those with the addition problem. Everybody's okay with that? Okay. So now that we've identified these two numbers, we're going to rewrite them, or use them to rewrite the 4x in the middle. So notice that I really haven't changed anything other than the way this looks, right? 7x and negative 3x still add to give me 4x. Does it matter which one I put first and which one comes second? No, you'll get the same answer either way. Your set of parentheses would be in the opposite order, but who cares, right? It's multiplication. You can do it in any order you want. Everybody's good here? Okay. So the process we're going to use now is called factor by grouping. So we're going to make one group with the first two items, and our second group with the second two items. And we must have a plus sign in between the two. That's why when I wrote down the problem initially, instead of writing 7x minus 3x, I wrote it as plus a negative. Okay? Everybody's cool? So from the first group, I can take out a greatest common factor of x. From the second group, I can take out a greatest common factor of negative 3. Is everybody okay here? Now, if I look at this as one thing, and this is one thing, I'm going to look for another greatest common factor. What's in common between x times x plus 7 and negative 3 times x plus 7? Well, the x plus 7 part, right? Everybody see that? It's in common to both. So I can factor that off. leave me with x minus 3. This process here is called factor grouping. Now I acknowledge some of us may know shortcuts in doing this to where we don't have to do the factor by grouping at all time. That's great. I'm going to ask that you sit on those shortcuts until we kind of introduce them in class, because this process that we've outlined here is necessary that you're able to do in some situations. So it is not an optional process. There are going to be times where some things we're going to have to factor using this method. And there's going to be other times where we can employ some shortcuts to not have to do this full method. But you do need to know how to do the full method. So until I've told you to, you can use your shortcuts, I do need to see the factor by grouping steps going on. Okay, so that means in your homework. And then eventually we'll get to the point where it's like, look, I want you to use the most efficient method possible because we just need to do this fast and get it over with. And at which point we'll give you all the shortcuts and make sure that we're comfortable using them and really kind of streamline this process. But for right now, if we don't learn how to do this factor by grouping method, like it tends not to happen. We just try to avoid it. So I want to start with the factor by grouping, and then it'll get shortcuts off of it rather than starting with shortcuts and then trying to add the factor by grouping on at the end. Everybody's okay with that? And again, many of us probably in our Algebra 1 class have already done some of this, right? And that's great. If you haven't, that's okay. We're starting this as if nobody's done it at all, because it is, I think, the most important skill that we work on in this first Algebra 1 class, or Algebra 2 class, this first semester. Okay, so let's do some practice here. So let's say we want to factor 12x squared plus 16x minus 35. So we'll start by determining the two numbers that multiply to give us 12, which is negative 420, and then add to give us positive 16. So it's probably not obvious right away what those two numbers are just by looking at it. These numbers are probably big enough that we're not going to see them right away. That's okay. So let's start by just kind of making a list. So we'll have things that multiply to give us 420 and add to give us 16, and we'll just kind of do this exhaustively. So I'm just going to go factor by factor. It works. What do you notice with each subsequent factor? You should notice that we're getting closer and closer, right? So 8 doesn't go, 9 doesn't go in, so I'll skip that. 10 obviously works. 11 doesn't go in. 12 does. 13 doesn't go in. 14 does. That's the one, right? That's the pair we needed. So again, do you need to write all these things down that I'm doing? No, I'm just writing this down so you can kind of see, like, what would I be doing on my calculator for a problem that's this big if I didn't see the numbers right away? It's just exhaustively going, starting at 1 and doing every factor until I've checked them all. Everybody's okay with that? Okay. So we have negative 14 and positive 30. Then we'll make our two groups. From the first group, the greatest common factor is 2x, leaving me with 6x minus 7. From the second group, the greatest common factor is 5, leaving me again with 6x minus 7. If you've done this correctly and chosen the correct two numbers, the two parentheses there should be identical, like we have. So then if I look at these as each their own separate thing, what's the greatest common factor? Six x minus 7. When we factor that out, what's left? And that's our final answer. Now keep in mind that this is not technically in intercept form. This is factored. Why is this not in intercept form? Remember, this. X is 1. What's our leading coefficient over here? 6 and 2. So is there a way for me to put this into intercept form? Well, I'll just factor a 6 out, and I'll factor a 2 out. So it really becomes 12 times. So that's really what our intercept form would be. Right? Is everybody okay with that? Now, when we say factor, we just want this thing. Right? A slight difference between factored form and intercept form. Intercept form, we require the leading coefficient on the factors to be 1. In factored form, we don't care. It's okay with that? We'll talk about a time where we care whether it's in factored form or intercept form. But for right now, factored is fine, right? Cool? Okay. You want to do one more, or do you think we got this? Sure. So we have 15x squared plus 2x minus 1. So we start by finding two numbers that multiply to give us what? 15 times negative 1, or negative 15, and add to give us 2. These should be two numbers you can find fairly easily in your head. Does anybody see the two numbers? Negative 3 and positive 5 is correct. So we can then rewrite that as 15x squared minus 3x plus 5x minus 1. And then we'll make our two groups. From the first group, what can I take out? Very good. So that gives me 5x minus 1. Remember, when we're factoring these things out, we're doing division. So 3x divided by 3x is 1. It's not 0. Everybody's okay with that? If I look at the second set of parentheses, what's the greatest common factor there? One, right? There's always a greatest common factor. Sometimes it's just 1. So far, so good. What do we do next? Very good. Take another greatest common factor. This time it's the 5x minus 1. When that comes off, what are we left with? 3x plus 1. Ella. When you find the two numbers of 5 and 3, how do you determine which one is first? Doesn't matter. The only difference is if you switch the order, you'd have the 3x plus 1 first and the 5x minus 1 second. If you switch the order, that's the only thing that's going to happen. But it's still the same answer, so it doesn't matter. That's a good question. Man.
For the 2, is that just going to be the x? If at the very beginning when you said negative 3 plus 5 equals 2, is that number always just going to be x?
Yeah, so it's ax squared plus bx plus c. This is a times c. This one is b. So that's the same question every single time. Whether you're using a shortcut or not, we can still think about it that same way. So far, so good? Okay. So we'll do some more factoring practice in the homework to get comfortable with this method, but you guys seem like you're in a pretty good spot with it right now. The other thing that we want to talk about today is this completing the square idea. So let's talk about that. So here, the completing the square is going to take us from standard form to vertex form. And again, it's been some days since we've done this, so I'll just write down again what standard form and vertex form look like. Okay. So here is the idea. Yeah, let's just do an example. It'll be easier to do it. Okay. So the trick here is going to be getting some part of my standard form polynomial to factor like that. Okay, with that idea? So once my leading coefficient is 1, which is already what's happened in this case, what we're going to do is we're going to add and subtract the same number so that we can factor part of this standard form polynomial. So it looks like that part that I've highlighted. The way we do that is we're going to add and then subtract b divided by 2 squared. So what number is the b in this case? 4. 4 divided by 2 is? And then 2 squared is 4. 2, add 4, and then subtract 4. So what have I really done here? Nothing, right? If you add 4 and then subtract 4 right away, you've done nothing at all. Everybody agree? It's still the exact same thing. It just looks a little different. What I'm going to do then is I'm going to take this piece, and I'm going to factor that. So, the neat thing about the way this is going to always factor is that it's always going to factor to x and then either plus or minus b over 2 squared. So in our case, that is just going to factor to x plus 2 squared. Right? Our b was 4, so b over 2 is just 2. If you wanted to check that, if you did x plus 2 times x plus 2, you get x squared plus 4x plus 4. Then we're going to do negative 4 plus 5 is just 1. And we're done. That doesn't seem so hard, Mr. Kulik. Well, let's do another one where the numbers get a little less convenient. Sound okay? All right. How gross do you want this to get for the next one? Let's not get it too bad, right? Let's not make this too bad yet. We'll wait for the third example for it to be as bad as it's going to get. Sound okay? But let's do this. Let's make that a minus 24. Okay. So the first step is we got to make the leading coefficient 1. Is the leading coefficient 1 right now? No. So we're going to have to factor a 2 out. Now, conveniently in this problem, everything was divisible by 2, so I didn't end up with any fractions. Will that always be the case? No. The third example we give you, we're going to get fraction city, so get ready for that. It's going to be a lot of fun. Everybody so far so good? So my b in this case is really this negative 12, just FYI. We're no longer looking at the negative 24. That's not really our b because we factored this piece out. Okay with that? So now we're going to add that b over 2 squared. So b divided by 2 is 6. 6 squared is 36. Where am I going to write the plus 36 and minus 36 at? Inside the parenthesis, outside the parenthesis, one of each. Where should I put them? They both have to go inside. That's correct. So far, so good. Now, I want to kick these two out of the parenthesis because I don't want that stuff involved with my factoring. Right? Everybody agree with that? How do I kick those out of that parenthesis? Before, I could just wrap the parenthesis around the stuff I want and ignore the other stuff, right? This one, I already have the parenthesis there, so I need to somehow boot those last two numbers out. Can I just do this? No, why not, Sydney? Yeah, because what didn't happen? So in order to get rid of, to move these out, if I distribute the 2 to both of them, then I can kick them out, right? So that's what we'll do. Now it'll be the same, right? Everybody agree with that? That's okay? Good. Now we can factor. So how does x squared minus 12x plus 36 factor? X plus b divided by 2 is close. -6, because the b is -12. And then 72 plus 10 is, or -72 plus 10 is -62. And really, we could just write this as x minus 6. There's no reason to write it as plus a negative. And we're done with that. How did I get the what on the outside? Which is the same thing as that. So we just skipped this because it factors that same way every time. We can just get around with it, get away with it. Is that okay? Because this is just b over 2 every single time. That's the beauty of this completing the squares. We force it to factor this specific way because of that number that we add and subtract. It makes it so that factoring is the way it's going to work. Okay? FYI, this kind of polynomial, and that's where this name completing the square comes from, is because by adding and 6, we made a perfect square polynomial. That's where the completing the square comes from, that name. All right. I promised you it was going to get ugly, could possibly get ugly. Let's look at that. Okay? Worst case scenario. And it's really no harder than the previous one. It's just going to get more fraction-y. Okay. First step would be 2. Yeah, factor out that 2. So in doing that, we have to divide everything by 2. Everybody's okay there? And on some of these, I'm going to include a little bit of extra work because some of the fraction calculations are not going to be quite so trivial. So I'm going to maybe write down a little bit more here than I did last time, just so if you're looking back at it, it's a little bit more clear what exactly happened. Just FYI before we start doing this. And you start going, this is so much longer than the last one. It's like, well, I just wrote down more. Anyways, next up, what do we do?
B divided by 3 squared.
Okay. So in this case, that's 3 over 2. 3 over 2 divided by 2 is the same thing as 3 over 2 times 1/2. So that's 3 over 4, right? 3 over is the same thing as 3 squared over 4 squared, 9 over 16. Everybody's okay with that? Now what should we do? Great. So we'll do that to kick those last two numbers out. So we can reduce these and then just multiply across. Everybody's okay with the fraction operations I did there? Okay. So we can factor. How does that factor? It's going to be x plus b over 2, right? What's our b over 2? 3/4. Notice I didn't even try to factor that polynomial by hand. It would have been pretty yucky. We could have done it still using our rules, but it would have been, that would have been bad, right? So if I FOIL out x plus 3/4 times x squared plus 3/4 x plus 3/4 x plus 9 over 16. 3/4 and 3/4 is 1/2, or 1.5, excuse me. So it is the same thing, right, Maddie? Mm-hmm. So I didn't drop it. I factored, right? I just wrote it in a more condensed form. Is that okay? Yeah. Okay. So just, it's still the same thing. I've just factored. And then to combine the 9 over 8 and the 5, we need to have a common denominator, right? That common denominator would be 8. So if I multiply 5 by 8 over 8, I get 40 over 5. Or, I'm sorry, 3 over 8. So that's negative 49 over 8. So there's my final answer there. Again, really I don't think any more difficult than the previous problem, just a lot more tedious because you had all these fractions rattling around that you're like, how do I divide a fraction by 2? Which is fine, like, you know, like we're still learning. It's okay to hesitate on stuff like that, but that's why we did the example, just so we can see some of those situations where some gross stuff can happen. Everybody's okay with that? Okay. So now we have our complete simplification map, right? So intercept form to standard form to vertex form. So FOIL, factor, complete the square, expand. So what if I ask you to do this? Convert to vertex form, 2 times x plus 1 times x minus 3. Well, let's look at our map. Where we what is our starting location? Intercept form. Where are we trying to end at? Vertex form. So how are we going to get there? We're going to FOIL it out to get to standard form, and then do the completing the square process to end up at vertex form. Everybody okay there? Okay. So if I FOIL this out, so I have that. And I could keep foiling, right? But that's not going to help me any, because the first step in completing the square would be to factor that 2 back out. So I'm just going to start completing the square right now. Is that okay with you guys? Okay. What am I adding and subtracting? What number am I going to add and subtract here? 1. Very good. That's negative 2 divided by 2 squared. Okay. Now what? Kick them out. I guess I could have combined like terms there too. Whatever. You know. And then we can factor. How does x squared minus 2x plus 1 factor? It's minus 1. And then we negative 2 and negative 6 is negative 8. Okay. So what if we want to write this in intercept form? Where are we currently located? Vertex form. So to get to intercept form, we're first going to have to expand to put it into standard form, and then factor to get it into intercept form. Very good. Okay, so let's start expanding. So I can just FOIL that out. And when I combine my like terms, I have that. Okay to there? Okay. So to factor, we need the 2 numbers that multiply to give me 1 times negative 5 and add to give me positive 4. Those 2 numbers are? Very good. Right, x squared minus 1x plus 5x minus 5. Make our 2 groups. I can take an x from the first group and a 5 from the other group. And that'll give me x minus 1 times x plus 5. Everybody okay there? Okay. One thing worth noting. Going from intercept form to vertex form, you'll never have an issue being able to do that. The verse, though, sometimes we're going to have some problems. Why? What part of that process could we run into some trouble? So the factoring piece, right? Yes, very good. So I should say our factoring doesn't always work. So just as an example, let's say we had this. Just doing the same thing that we did before, we know x squared plus 2 foiled out, or x plus 2 squared foiled out to be x squared plus 4x plus 4. I'm just taking advantage of work that we did in the previous problem to speed things along, to show you guys where the issue comes in. I'm not trying to do anything magical. I'm just piggybacking off work that we did in the previous problem. We're all okay with that? Okay. And if I subtract I have this. But if I look for two numbers that multiply to give me 2 and add to give me 4, no two integers do this. So we don't have a way to factor this using the methods we've currently presented. Now let me be clear. All quadratics are factorable, depending on what you're factoring over. Right now, we're only worried about situations where we can have integers as our factors, right? What if there's a way to do this without integers? We'll get to that later this chapter, but I'm just kind of planting that seed right now and pointing out to one of the major drawbacks we have with our factoring technique is that it doesn't always work. It may not always be possible, like in a situation here. Okay with that? So for right now, we can say that that's not factorable. That's fine. We'll clarify what that means as we go further on into this chapter, but that's an okay response for this right now. And I think we've done enough for today. We did a lot. Those are two relatively difficult techniques that we threw at you at once. You guys did a good job, though, at figuring out right away how to combine, the trip through that simplification table to use the appropriate methods to get where we're trying to go. So I was pleased with that. And in general, seem to be catching on how to do these things pretty quickly. I'll post an assignment later today for you guys to work on, to practice factoring, and then this completing the square pieces. Actually, let me look right now. I think I might have those ready that I can just put in the content library right now, since we have the time, No reason for you guys to sit around waiting for me if I have it ready, right? Yeah. Let me look. I did a bunch of homework creation last time. I just want to make sure that these are what I'm looking for. This just needs to stop.